Hello, pre-calculus students. Today we are going to talk about the last section in chapter 7, which is 7.5, solving trig equations. So you'll want pencil, highlighters, your notes for 7.5, your unit circle. As we're going through this, you want to make sure that you're pausing to try the problems. Okay, so solving equations. Let's take a look at our examples here. Notice in this first example, I did add an additional part C. Okay, so there are 3 examples. Each one has a couple of parts. And first, I want you to take a minute and just look through the directions and see what you notice about the differences in the directions. And the first one says to solve each equation for principal values. It says to express your solution in degrees. The second example says to solve each equation, and it gives an interval from 0 to 2 pi. And in the third example, it says to solve each equation for all real values of x. So how we solve is going to be similar in all of them, but how we give our final answers is what is really going to vary. Right? And just as when we did trig identities, when we proved them, there were some different strategies. There'll be different strategies here too. So it won't be that every single one of them is exactly alike. The first few maybe start out that way, but then there are different strategies that we'll pull in. So the idea is that we want to get the x by itself. So if you look at part A, if that didn't have a sign of x and you just had to get x by itself, think, okay, what would your first instinct be to solve that? Okay, so you might say, I'm going to subtract the 1 from both sides and then maybe divide by 2. And you get to the point where you have sine of x equals negative 1/2. We solved equations like this back in chapter 5, where we were solving our triangles, and we talked about taking the inverse sine of both sides to get the x. And we're going to do that here. But remember in chapter 6, we talked about taking inverses of sines, cosines, and tangents. And remember, we had the capital S for inverse sine and C and T for inverse tangent. Remember what that meant was that we gave our answers on a specific interval. When it says to solve for the principal values of x, that means you need to give your answers from the restricted range. So remember when it was inverse sine, our answers fell between, if we were in radians, negative pi over 2 and pi over 2. Now this does say in degrees, so if we were talking about degrees, we would give an answer between negative 90 and 90. If we were using inverse cosine to solve, our answers would fall between 0 and pi if it said to give our answer in radians, and 0 degrees and 180 degrees if it said degrees. And then inverse tangent, similar to inverse sine, but parentheses because it's undefined at the endpoints of the intervals. So from 0 or negative 90 rather to 90, but parentheses because we're not including those values. Okay, so it's very important that you pay attention to the directions. Principal values means our answer has to fall in these intervals, and in this case, your answer needs to be in degrees. So what we're going to do is we're going to take the inverse sine of both sides, and I'm going to use that capital S when I do it, because that is going to help me to remember that I have to give my answer within that interval. So x is going to equal, we're going to look at our unit circle. Remember, when we're doing inverses, we're thinking at what angle is the sine negative 1/2, and it has to fall on the interval from negative 90 to 90. So at what angle do I have a y value of negative 1/2, which would be right here? Remember, I can't call it 330 degrees. It doesn't fall between negative 90 and 90. Instead, I have to think of it as going back 30. So x would be negative 30 degrees. So I'm going to use the same idea for part B. First, I'm going to isolate the term or the trig function that has the x on it, and then I'm going to do the inverse. So I would first add the root 3, and if I were you, I would try this on my own first, and then divide by the 2. And then I want to find the x, so I have to take the inverse cosine. And again, because the directions say for the principal values, I'm going to do the capital C inverse cosine of both sides. So that means, right, this means my angle has to fall between 0 and 180. Just like up here, that capital S meant my answer had to fall between negative 90 and 90. Okay, so I look on my unit circle, and where on the unit circle between 0 and 180 is my cosine root 3 over 2. That means my x value is root 3 over 2. That happens right here at 30 degrees. Okay, so x is 30 degrees. And you might have been saying, well, hang on, the cosine is also root 3 over 2 here, and it is, but remember, it said principal values. That means we only give answers in that restricted range. Okay, now this last one, a little bit different. The 2 is inside the argument with the x, so it's a sign of 2x. I cannot divide that 2 off. Okay, it stays in there for now, but what I can do is get rid of that sign of x by taking the inverse sign of both sides. Again, a capital inverse sign so that I give my answer between 0 and 90. When I do that, instead of being left with just x, I'm left with 2x equals the inverse sign of 1. So that means I'm looking between from negative 90 to 90. Where is the y value 1? That happens at 90 degrees. Now, I do have one last step here. I actually have to divide by 2. So x is 45 degrees. So if that ever happens, no matter if it was sine, cosine, or tangent, you would solve and then get rid of the trig function and then do the division to get the x by itself. I wanted to add that because I know it comes up in the homework, but I didn't have one in my notes. Okay, so now let's take a look at example 2. It says solve each equation, and this says on that interval from 0 to 2 pi. So that means you're going to give any answer, right, that falls in that interval. Okay, so when it says from 0 to 2 pi, the first thing that tells me is my answer should be in radians. So it didn't say that explicitly, but if my answer falls between 0 and 2 pi, that means my answer has to be in radians. And so I'm going to give any possible solution that falls on that interval. So any solution within the interval. So like in the last one, how we talked about, like cosine is root 3 over 2 in two different places. Okay. If it had just said, solve from 0 to 360, I would give both of those answers. And so that's what I'll do here. Okay, now looking at A is a little different than the other ones because it's got two terms and they both have trig functions attached to them. So it's not like up here where these were just a number and I could just move it over. If I move over that half cosine x, it doesn't really help me in any way. So I have to think of other solving strategies that I have besides just, straight up isolating the variable because a variable comes up with two different trig functions. So I notice that I have two terms, and in each of these terms, I notice a cosine of x. So one of our strategies that we can use to solve these is to factor. And it might be box factoring, or here I could pull out a greatest common factor. So here I would be left with sine of x minus 1/2 equals 0. Because if I did cosine times sine, I would get back to here. If I did cosine times negative 1/2, I would get back to here, and then equals 0. Remember, whenever you're using factoring as a strategy to solve, you want to have equals 0 on one side to do it. The reason is because you can now use that zero product property back from algebra and algebra 2, which says that if you're multiplying two things together and your answer is 0, one of those two things has to be 0. So the idea is that I set each of my factors equal to 0 and then solve for x from there. Okay, so in this case, there's nothing to get off of the cosine of x. I'm going to take the inverse cosine of both sides. Right? And I'm not using the capital C in this case because it can be anything on this interval. The capital C means only answers between 0 and 180 or 0 and pi. Here I can give any answer between 0 and 2 pi. So I'm going to look at my unit circle. Where on my unit circle is the x value 0? That's what I'm looking for on my unit circle. So where on the unit circle is my x value 0? 0 here, and it's 0 here. Okay, and it says between 0 and 2 pi, so I have to use the radian answer. So pi over 2 and 3 pi over 2. So my answers are pi over 2 and 3 pi over 2. So there are two possible answers that would make this equation equal 0. And then I have to solve this equation. So I would add the 1/2 and then take the inverse sign. Again, just the regular inverse sign, not the capital, because I want to give any answer that falls between 0 and 2 pi. So I have x equals, and then I'm going to look at my unit circle. Where on my unit circle is my sign or my y value? 1/2. I see that here at pi over 6, and I see that also here at 5 pi over 6. Again, we're giving our answers in radians because that's what the directions were. Okay, so here are, I've got 4 solutions in this case that would make this equation true. So let's take a look at the next one. So this next one, I see I've got a sine of x squared. I got a sine of x and then no sign in here. So I don't have a GCF. I don't have any like terms. So it's a trinomial, right? And this is squared. So what we're going to do is we're going to use the box to factor. We had to do that earlier in section 2 when we were doing identities. Again, the directions for these are the same as on the other side that we're solving on the interval from 0 to 2 pi. So we're giving our answer in radians. And so we're going to solve this using a box. I'm going to do it over here out of the way. So we talked about this before. When you solve using a box, your square term goes in the top left. Your constant goes in your bottom right. This diagonal here has to multiply to be the same as this diagonal. So if I multiply these together, I get -2 sine squared of x. The diagonal also has to add up to equal your middle, which is sine of x, or 1 sine of x. So the idea is everything in your box should total up to be this. And then these would be the things that would multiply to total up to be that. Okay, so what are 2 things that multiply to be -2 and add to be +1 would be 2 times -1. So 2 sine of x and -1 sine of x. So if I multiply these 2 together, again, I get -2 sine squared of x. And if I add them, I get 1 sine of x. So then I'm going to pull a GCF out of this row here. So I would have 2 sine of x. It really doesn't matter where you pull the GCF. Pick a row or a column and start there and then work from there. I usually pick the top row. That's just what I do. It's not the only way to do it. Okay, so then I think 2 sine of x times what would get me 2 sine squared of x? That would just be a sine of x. And then 2 sine of x times what is 2 sine of x? I would need a 1. And then sine of x times what is negative sine of x? So I would need a -1. And if you did it right, when you multiply these together, you get your last box, which I do. These are my factors. So if I multiply these together, it will give me this, which would total this. Okay, so I'm going to write this as my 2 factors. Sine of x plus 1 times, 2 sine of x minus 1 equals 0. Okay, so now once I've done that, I'm going to use the same idea I did in the last one, where I'm going to set my 2 factors equal to 0 and solve. Okay, so here I could subtract the 1. So sine of x is -1. And then I'm going to take the inverse sine of both sides. And I'm going to look on my unit circle at what angle is my y value, -1. Here, and I want my answer in radians. So 3 pi over 2. Over here, I'm going to add the 1 and then divide by 2. So I'll have sine of x equals 1/2. I'm going to take the inverse sine of both sides. And I'm going to look on the unit circle. This has come up a bunch of times. It just so happened to finding the inverse sine of 1/2, which we know that is pi over 6. We just did this a second ago, right? In 5 pi over 6, where the y value is 1/2. That was not on purpose. Actually, if I planned that better, I would have made them different, right? Okay. All right, so I have 3 solutions for this one. Okay, so take a look at the next one and see what you think, or what's giving you difficulty about that one. Okay, so there are a couple of different ways to go with this one. I do notice that I've got 2 terms involving sines, and then I've got this cosine squared. And so it's like, oh, what am I going to do with that? You might think, well, I could I could subtract that cosine squared over, kind of get everything all on one side, and then I'll at least have the 0. There's more than one way to come at this one, so I'm going to do it one way. You might have seen it another way, and it would totally work. I'm going to subtract the cosine squared over. So I have sine squared x minus sine of x plus 1 minus cosine squared of x equals 0. And I'm thinking my life would be a lot easier if I could have just sine squareds in there. And so I'm going to go to my identities. Is there anything in here I could swap out? Okay. So this 1 minus cosine squared, that's one of my identities, right? That Pythagorean identity, sine squared plus cosine squared equals 1. If we were to subtract the cosine squared, remember we used this a bunch when we were proving and simplifying identities. We know that that is equal to sine squared of x. So those identities can be used. So I have sine squared of x minus sine of x, and then plus the sine squared of x. Now these are like terms. So I have 2 sine squared of x minus sine of x equals 0. Okay, so all of that math magic, now I'm left with 2 terms and they both have a sign. Well, now I can use factoring by pulling out a GCF. So I could pull a sine of x out of each of these and be left with 2 sine of x minus 1 equals 0. So if I did sine x times 2 sine x, that would get me here. If I did sine x times negative 1, that would give me this minus sine x. So I pulled out that GCF. Then I can use the idea of setting my factors equal to 0 and solving. Man, this one is just in here a bunch of times, right? If I add the 1, divide by 2, get sine of x is 1/2. I don't know, this is like the 3rd time we've done it. I need to work on these examples. But I know the answers, so that's nice. So I know x is pi over 6 and x is 5 pi over 6. Here I would take the inverse sine of both sides, so the inverse sine of 0. I would angle, or angles, are the y values 0. Oops. So if I look where my y value is 0, my answers have to be between 0 and 2 pi, not including the 2 pi. If you looked at the interval, it didn't have it equal to on the 2 pi. So here are my y value 0, here my y value 0. So at 0 radians and at pi radians. Okay, so 0 and pi. Okay, again, the reason I couldn't pick 2 pi, the directions were to give answers from 0, including the 0, but not including the 2 pi. So you just go all the way around once with no overlap. Okay, so there are my 4 solutions. All right, now the next set of examples says solve each equation for all real values of x. Well, remember how we just said at 0 and 2 pi, the angle has a sine of 0? And really, I could just keep going around, right? I could say 0, 2 pi, 4 pi, 6 pi, 8 pi, and so on, right? We have all those coterminal angles. Same thing here. I could do pi, 3 pi, 5 pi, 7 pi. So when the directions say solve each equation for all real values of x, that means that you want to include all possible coterminal angles, right? Because you could keep adding multiples of 2 pi or adding multiples of 360 if you're in degrees. So when it says all real values of x, that means you need to include all possible coterminal angles. So if the directions say to give your answer in radians, you're going to add 2 pi n. If it says to give your answer in degrees, you're going to add 360n, where n is an integer, right? That takes care of the positive and the negative of that. Okay, so that's what this direction here means for all real values. So like I said, it's going to be important to read the directions, especially in your homework and on the test, even more importantly, so that you're making sure that you give all the information you're being asked for. Okay, so first one, I know it's got a tangent in there. It's a tangent squared, but it only has one trig function in there. So I want to get that thing by itself. So I'm going to add the 1. I'm going to divide by the 3. So I'll have tangent squared of x equals 1/3. right? I added 1 to both sides, and then I divided by 3 and get tangent squared equals 1/3. All right. So then I want to get rid of the squared on the tangent. I just want the tangent of x. So the inverse of squaring is to take the square root of both sides. So now I'm left with the tangent of x equals, now this is important, when you take the square root of both sides and you're solving an equation, it could be positive or negative square root of 1/3. Now, I don't really want to leave it like the square root of that whole 1/3. I want to think of it as a square root of 1 over the square root of 3. And I kind of want to go further than that too. So really, it's plus or minus the square root of 1 is 1 over root 3. That doesn't look familiar from my unit circle. I want to rationalize that denominator. So really, I have the tangent of x equals positive or negative root 3 over 3. Okay, that makes me feel a little better because I know that's on my unit circle. So when you do this, when you take the inverse tangent, you want to take the inverse tangent of both the root 3 over 3 and the negative root 3 over 3. So you want to be careful that you're doing that and that you are including all the coterminal angles. Okay, so we're going to have x equals, and I'm going to write this out, the inverse tangent of root 3 over 3, and it has to equal the inverse tangent of negative root 3 over 3. You don't necessarily have to write out both of them. You just have to make sure that on the unit circle, you're looking for all of them. Okay, so root 3 over 3, the tangent is root 3 over 3 here, and then over here in the third quadrant. Okay, so here and here. So at pi over 6 and 7 pi over 6. So x equals pi over 6 and x equals 7 pi over 6. Technically, this did not say I had to give my answer in radians. I just did. But it didn't specify. I could have given it in degrees. Now, I'm not quite done with this because I have not dealt with the coterminal angles yet. I'm going to get just the initial values, and then we'll talk about the rest of it. Okay, and then it's negative root 3 over 3 here at 5 pi over 6 and here at 11 pi over 6. So 5 pi over 6 and 11 pi over 6. Now, there are a couple different ways you could write this answer. One would be to do what we set up here and just tack 2 pi n on all of them. You have to do it on all of them. You have to tack it on. Otherwise, you're leaving out infinitely many solutions. If you don't include it, you've really only solved it from 0 to 2 pi. You haven't solved it for all real values. So you really want to be careful of that. Now, the other thing, and some of you might be noticing this, is that you could condense your solution. Okay, because our solutions are at pi over 6, and then over here at 5 pi over 6. They're all the sixths, right? All the things that are over 6. Right. So what I could do instead is instead of naming pi over 6 and 7 pi over 6, what I could do is to get all these coterminal angles is I could just, to the pi over 6, I could add pi and then add another pi to get to the next one, and add pi and add pi and add pi and add pi and keep adding pi. And that would get me all of those angles. So another way that I could write this answer is I could write pi over 6 plus just pi n. And that would get me all of these solutions that are coterminal to these. And then to get all the coterminal angles to these, I could just start with the 5 pi over 6 and say, okay, I'm going to add pi and then add pi and add pi and add pi and add pi. And that would get me all of those. So then I could have 5 pi over 6 plus pi n. Okay, so this is an alternate answer. I personally will take either. The book will probably give this as your answer. So just, be aware of that. All right, last example. There's a good chance you're looking at that and saying, that looks terrible. There's 4 terms. There are 4 terms. Nothing's squared, though. Here, these have signs in common. These have root 3s in common. It is equal to 0, so that sort of makes me think about factoring. And if you remember when we factored, we had a method called factor by grouping. And what we could do with that is we would just put all 4 terms into our box. So here I could put my 4 cosine x sine of x minus 2 sine of x minus 2 root 3 cosine of x, and then my root 3. Okay, order, like if I put this like vertically, that doesn't matter. You want to kind of put them in there so that you have the things that have something in common together, either horizontally or vertically. All right, then I'm going to do the thing where I pull out greatest common factor. So if I start here, I could pull out a 2 from each of these and a sine of x. So I could have 2 sine of x, and then this would be 2 cosine of x, right? 2 times 2 is 4, sine times cosine would get me this. Then if I have 2 sine x here, this would have to be a negative 1, so it multiplies to be this. Here I've got 2 cosine x, but I need it to be negative root 3 cosine of x, so I need a negative root 3. And if I do a negative 1 times a negative root 3, I get my 3. So here are my factors. So this turns into 2 cosine of x minus 1 times 2 sine of x minus root 3. Okay, set my factors equal to 0. And then solve. So here if I add the 1 and divide by 2, I get cosine of x is 1/2. Here if I add the root 3 and divide by 2, I get sine of x is root 3 over 2. Finally, not a 1/2. Mixing things up. So then I'm going to take the inverse cosine of both sides here, and inverse sine of both sides in the other. And I'm going to look on my unit circle, and where is my angle? 1/2. And let's do degrees this time, just so you see what that would look like. You could totally do it in radians. That is fine also. Okay, cosine is 1/2. Here at 30 degrees, no wait, here at 60 degrees cosine, and then here at 300 degrees. Okay, so at 60 degrees and at 300 degrees. And because the directions for this are all real values, I would add 360 n. Okay, sine is root 3 over 2. So at what angles are my y values? Root 3 over 2. So I see that here at 60, and then again at 120. So this has a repeat solution. Really, I don't need to include it. Again, it's already there, right? Don't technically need that. You could include it if you wanted to include it. You don't have to include it. And then what did I say? 120 plus 360 n. Now, the 120 and the 300 are directly across from each other, right here and here. So I could condense that, right, and just say I'm going to add 180 each time to get up to all those coterminal angles. So if you wanted to condense this, you could. So first of all, I could just say the 60 plus 360n. I could just say that once, and then I could say 120 plus 180n to condense that other part. So this could be my alternate answer. Again, I would take either answer. This is more concise though. Okay, so that takes care of solving equations. There are lots of different strategies that you're going to use. Just kind of take it one step at a time. Remember, you have your trig identities, and make sure you're paying attention to the directions so that you're giving your answers in the correct solution interval.